Hello, welcome to Chapter 13. The whole chapter is called Similarity, and we are going to start by defining similar polygons and applying the property of proportionality of sides, things that we have done probably in middle school, but we're going to talk about them as they represent side, 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 and side, angle, side similarity theorems. Okay, so we've talked about the congruency theorems, so now we get to talk about similarity theorems. So the first section is similar figures. Okay, so the definition of similar polygons are polygons having corresponding angles that are congruent and corresponding sides that are proportional. If triangle ABC and triangle DEF are similar, then the proper notation is the triangle ABC with one little squiggly, that means similar, to triangle DEF. So what exactly does triangle ABC similar to triangle DEF mean? Well, it means that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. And the order of those angles, how they're listed, matters a lot. It also means that side A is proportional to side AB is proportional to side DE, which is also equal to BC is to EF, CA is to FD. So these are proportions that we can set up and solve for sides we don't know. A ratio is just a comparison of two numbers, and it's basically a fraction that we use in a certain way. A proportion is an equation with two ratios. So hopefully this is just a little refresher on how we set up proportions, and we cross multiply. So if we need to solve x divided by 5 equals 9 divided by 15, we could multiply both sides by 5 and come up with the answer, or we could cross multiply. If I cross multiply, I get 15x equals 9 times 5, which is 45. So then I can divide both sides by 15 and get x equals 3. So hopefully this little bit of algebra is coming back to my geometry students. Now let's apply this to triangles. So if I have A prime B prime proportional to side AB, that means 8 is to 16 as 1 is to 2, which makes sense because 8 is half of 16. And then A prime C prime is to AC as 4 is to 8, which is also equal to 1/2. B prime C prime is to BC as 6 is to 12, which again is 1/2. So all of these sides are proportional by 1/2. And they are all proportional to one another. So therefore, triangle ABC is similar to triangle A prime, B prime, C prime. And the way that we proved that by checking all three proportions. You cannot check just two. You have to check all three because your book likes to trick you with just one side. So if the corresponding angles of two polygons are congruent and the corresponding sides are proportional, then you know the two figures are similar. So you can go backwards in our definition and prove similarity. Okay, so that's the entire lesson. I've given you some practice problems to solve here. I think there's 5 of them. So remember to submit those through email and check your answers when you get the reply, and I'll see you in class.